Good day, good day, good day, good day, everyone. I'm Shongane Wongwe. Today we'll start on our lesson of mechanical technology under the topic of forces, grade 10 mechanical technology. Okay, the lesson for today uh, we'll start on the different types of forces found in engineering component. Then you must know the different types. There is three different types of forces, which is pulling force, compressive force, and shearing force. Okay. Then we come to moment. First of all, you must know how to define what is moment, and then you define using the yeah, I will show you using the formula or a moment is equals to force multiplied by perpendicular distance. Therefore, we do the basic calculation on stress. And we do the basic calculation on square bars and round bars. So today we'll cover this topic. I will shorten it. I'll shorten it. I'll shorten it. Okay. Now we are starting our we we are starting with our lesson. Okay. Okay. We said there is three three types. Three types of forces, né? Okay. We have three types of forces. One, we say is a pulling force. A pulling force. Okay. I will show you an example of pulling force here. Let's take the diagram is inclined. Let me show you the example of pulling force. Let's say this is our surface. I'm not good on drawing, so don't mind my drawing. But let's continue. Okay, we're on pulling force. Is when like the object is inclined like this. Therefore, it's been pulled. It's been pulled. It's better. It can be pulled upwards. It can pull upward like this. This is the example of what? Of pulling force. This is the example of pulling force. We can call it T, attention, because it's pulled by attention. It can be pulled, it can be pulled by different things. Yeah, it can a block on an incline, it can be pulled, and therefore it goes upwards or goes downward using what using O. Okay, number two, I can show you the example of what this is. Number one, we are coming to number two. We say we have three types of different forces. Now we are coming to compressive force. Compressive force is when we have an incline like this. We have incline like this. We have incline like this. Okay. My drawing is better, but I will try by all means. You see, this is an incline. Let's take there is another object here. Yeah. Okay. You see here, there is a force here. There is also a mass that is pressurizing here. There is a mass pressurizing here. Remember, this is compressive force. It's when it's comprehend like mm, it's showing the force while it goes down and another force going where going in opposite direction. Obvious, if there is a force going down, there is also a force that is going up because this, remember, this is our surface. Okay, if we say we have a surface, okay, okay, if we have a surface, we have a surface like this one. Let me use another color. This we can call it the surface. You see, on top of red one. This is called a surface. Ne? If this is a surface and these two things there are what are the object or are the yeah. So that means this object are doing what? Are releasing the what? The force downwards because what this object they have surface have mass and that means on that surface it pressurizing downwards. Therefore, on even the surface itself, it can what? It pressures, it release a force, but in what? In different what? In different in different direction. It's like when Newton that law. They say if body A, if body A exert a force on body B. That means body B will also exert a force on body A. But what? Mark the words, ne? In different direction. That means this object is exerting a force downwards. It's exerting a force downwards, ne? You see, it's compressing it downwards. Therefore, even the surface, it will do what? Same thing. The force that will oppose but in different what? In different direction. But these two forces are equal. Yeah, we can say they are equal. You understand? They are equal because the surface is also what? Releasing a force. Even the object is releasing a force and it pressurizing it downwards, while another one is pressurizing it upwards. Okay? This one, remember, this one I was saying will okay, now we're coming to our three. Number three, we say, let's take, yeah, oh, my drawing is bad, guys. My drawing is bad. My drawing is bad, guys. So don't mind. Okay, number three, let me use black one. Let's take this is in incline. This is incline. This is our incline. Hmm. Yeah, this drawing is not perfect. Okay, this is our incline. The object is like this, on top of the incline. Okay, remember on sharing force, there is what here? Let's take here, there is a mg going where? Upwards. there is a what mg going upward. This is shearing force. Is when the force is being sharing. Yeah? It's when the force is being sharing, and the force of gravity to slide to the block down the steeper proper shearing residence to the point of contact. On inclined block trying to slide down. If this block try to slide down, it tries to slide down, the shearing it occurs at the what? At this, let me use the red one. Let me use the red one in order to identify it. When the object slides down, it fixed stopper at the base. It occur and block what? And need to block here to block this object. To block this object so that so that it does not go downwards. Because it needs to do what? To go downwards, but the surface is trying to act like a frictional force. When you go that side, it opposes you. That means if you are pulling that side, it also do what? Pulls you back. If you are pulling that side, it also pulls you back. Yeah, we have three types of what? Of forces. I say number one, I say three types of forces. Number one is pulling force. We can say PF, pulling force. Number two, we have a compressive force. We can call it CF. Number three, we have a shearing force. We can say is what? SF. I think now we know how to identify these three types of this is number two, guys. These three types of forces. Okay. Now we know three types of forces. We know three types of forces and example on the forces. Yeah? So now I will move to moments. I'll cover moments. Okay. We are now on moments. Then my moments. Ne? The moments. We must first know the definition of moment. The definition of moment. You must know what is the definition of moment. Okay, you know, moment is M. Now I'll give you the definition using what? Using equation. Moment is this one, M. Okay, moment is equals to force, the force multiply by what? The perpendicular distance. You can just write perpendicular distance, but always you know these things perpendicular and the perpendicular distance. And always that moment is measured at an it measured at force is also measured at Newton. And so we come to our distance. Our distance can measure at meter or millimeter. Sorry. Yeah. It can measure on meter or millimeter. So moment, if you want to calculate moment, you must have the perpendicular distance, you must have the force, then you are able to solve for this. Okay, if they could give you a moment and give you even a force, let me give you an example of like an example. Let's take they give you moment of 15. Just say they give you 50. They play hide and seek. So you must know the trick. The trick. They give you 40, 41, 40, 40, and ah, okay. They give you 50 nm. 50 nm. This you know when you say nm, it's for what? It's for moment. Then they give you 40, 40 what? 40 Newton. Okay, you know it's a force. They say calculate the exact distance or calculate the perpendicular distance. Therefore, when now you know you are coming to use this formula. It's not like always they will say you must calculate for moment. Sometimes they can trick you, they give you moment and forces, they say calculate this, or they give you distance and give you moment and say calculate this, or give you these two, then you calculate. So you know we are going to say first of all, you write the formula down so that you are not confused. You say M, let me use black so that you can see it. You say M is equals to, you know, F. This formula must stay. It's not this formula. Multiplied by perpendicular what? Perpendicular distance. Multiplied by perpendicular distance. Okay, they gave us this one. You first you know, okay, this one is this one is false. Okay, so that where there is M, I can substitute 50. I can substitute 15. Therefore, where there is F, I can substitute 40. Therefore, we know we are multiplying by what? By the distance, and the distance is perpendicular distance. Therefore, you can also write T. Then you see, okay, this is what you must do the subject formula. Then you have to do what? To divide by 40. Divide both sides. What you do on another side, you also do on another side. It's the same. Divide by 40. That means this side only D will be left because this one and this one will cancel. D will be equal to 50 divided by 40. Then you use a calculator. You come to a calculator, you say 50 divided by 40. You see, well, okay, the actual distance, the perpendicular distance will be 5 divided by 4. Remember, the SI unit of perpendicular distance is meter or millimeter. They will tell you measure in what? They will tell you. Yeah. Then you are done. You see? Simple. Then you are done. Okay. You on this lesson we're doing pulling force, compressive force, and shearing force. Then we come to moments. We define moments using equations. M is equal to F multiplied by perpendicular distance. Therefore, we do an example of calculating moments, calculating force, calculating perpendicular distance. So now we are coming to, we are here now. Now we are here. Uh, we are on stress. Let me use the powerful one, the powerful one. stress. Stress. We want to do a basic calculation of stress regarding to square bar, round bar. We know on stress we have what? Square bar, we have square bar. Okay. We also have a round bar. Okay. You know, when we calculate stress, stress is represented by this thing. This represents stress. Stress is equals to force, force F divided by what? By area, divided by area, divided by area. Ne? So when you are at stress, you must know what is stress. You must know when we say a square base or what, a square base, you know you know what we are talking about. When we say round base, you know what we are talking about. So F, this F is measured, in Newton always. F in Newton. Area is measured in squared. Squared. It measured in squared. So today we will end up our lesson here. First of all, you know what is you know what different types of what? Different types of forces, which is pulling force, compression force, shearing force. You know the to differentiate between them. You know moments, you know how to define moments using equation. You know stress and basic calculation of stress regarding to square bar and round bar. Thank you guys. Thank you guys. I will meet that time another day. Thank you. Thank you.